Right. Let's talk about modeling with quadratics a little bit. Mathematical modeling is actually one of the more useful reasons to have math. I mean, other than, keeping track of how much money you have in your bank account. But let's say we got a situation where a punter kicks a football and the football lands 40 yards, or we'll call it 120 feet down the field, and it reaches a maximum height of 85.2 feet. And I just grabbed some sort of average values of various things. And the question is, can we model this with a quadratic? Well, we're going to use the graphing form or vertex form of the equation, because one of the nice things about this is that we already know HK. We know that this is a parabola that has been transformed by shifting it 60 feet to the right and 85.2 feet up. And we're not going to worry yet about the fact that it's upside down, because that's going to come out in the wash when we calculate the stretch factor. So we can write the equation, y equals a, x minus 60 squared plus 85.2. Well, what else do we know about this parabola? Well, we know that there's a point at 0, 0, and that there's a point at 120, 0. We can plug one of those into our equation and solve for a. I'm going to use 0. 0, it doesn't really make any difference at all. And as an intellectual exercise, if it really bugs you, you can plug in 120, 0 and see if you get the same answer. But we get negative 85.2 equals a times, well, negative 60 squared, 3,600. Dividing both sides by 3,600, we get a is approximately negative 0.02367. Notice I did say that the negative would come out in the wash. You could put a negative in front of the a, but it just makes the calculations more complicated, and then you get a positive value of a. So we now know that the equation for this punted football is negative 0.02367 x minus 60 squared plus 85.2. And boom, we can use that to predict at any given time where the football will be. All right.